Hey, good morning. Welcome to
Math for James number 2.
Math for James number 2. We were getting a little bit bogged down on our algebra homework today, so we decided to take a little break, and luckily our friend on Twitter, James Tanton, proposed a really cool problem that I thought we'd make a video about. In tiling an 8x8 board with dominoes, must 2 dominoes form a 2x2 square? Okay, so do you understand the problem?
Yeah.
Alright, great. Well, luckily we had an 8x8 board laying around, and we have some Duplo dominoes, and so what I'm going to do, just to make things easier to see, is we're going to make our red dominoes go across that way and our blue dominoes go down like that, just for a distinction. And so, how do you think you'd like to approach this problem? I'm actually very curious to see how you think you want to approach trying to solve this problem.
Well, we should try not to make a square.
Okay, you want to try to find a counterexample. Let's try not to make a square. Okay?
Yeah. So, we can put these down.
So let's start in the corner. Okay? Let's back up even from now. Let's start in the corner. Okay? Does it matter what you do in the corner?
No.
Because you can put this down or up and it's actually pretty much the same. Okay? So the one in the corner either has to go one way or the other. Now, from here, what can you tell me even about the position from here if you're going to try to not make a square?
We only have a couple spots you can... Actually, you could just put one randomly over here.
Okay, so is laying stuff down randomly, do you think, going to lead you to discover the solution?
Probably not.
Probably not. So think about it. This is a chessboard, right? When we solve chess problems, we try to look for moves that are forced. Okay? Even having put one tile down, do you see anything that's forced here on the board now? For the next tile? Remember, our reds are going to go across this way and our blues are going to go down this way. So tell me if you can find a place where there's a forced move here if we're not going to make squares.
Well, I can see a spot where you go to not make a square. You can't go here.
Ah, okay, so put a tile there that you can't put. You can't put that tile there, otherwise you make a square. So what's forced now? What's forced to be a blue tile on the board?
One of these squares.
Okay.
One of these two.
Which one? That one is forced. Because if you put the blue tile there, what happens?
The blue tile has to go here.
Blue tile has to go here. So a blue tile goes there. So now do you see anything else that's forced now? If you're going to not make a square.
A blue tile can't go here.
Blue tile can't go there, so what's forced?
There's... A red tile has to go on here.
Ah, interesting. Okay, now, so do you see anything that's forced now? What's anything forced here?
We can't put a red tile on these two.
All
so
right.
These two have to be... this one has to be a blue.
Okay. Now you're cooking with butter.
But if we put a red here, then this square is going to be uncovered. So where else can we put it?
Look for things that are forced now.
A red has to be here.
Why?
Because of this blue.
Okay, because you can't put a blue here like that. Okay.
And
See anything that's forced now?
that's forced.
All right.
Neat little pattern. That's forced. That's forced. That's forced. That's forced. That's forced. That's forced. And that's forced. And then that's forced. No, wait, that can't be there though. So we have to make a square.
Oh. Problem. So the neat thing about this problem is if you try to not make a square, you can just start at the beginning and ask yourself, and it would have been exactly the same if we would have put it that way. You can say, okay, I want to not make a square. Where's the next thing? Well, all that means is I can't put something there like that. So this square here, A7, can't be a red one going that way, so it has to be a blue one. Now let's look at this square B7. It can't be blue like that, so it has to be red. Well, now let's look at this square, and then you start making this awesome pattern that goes right down the diagonal. You see that?
Yeah, but in the end...
But in the end, that leads to a problem.
Going down the diagonal the other ways would lead to the same thing.
Going down the diagonal the other way would lead to the same thing. And it all originates from just deciding what to do with this one first square there. That's a pretty neat problem, isn't it? And so it leads us, it's really instructive too, because one way you could start trying to solve the problem is by just laying down tiles randomly. And that's going to be hard because there's lots of different ways to put these tiles down on a chessboard, right?
Yeah.
So we've got to try to find some systematic way to think about it. Another way to think about it would be to start doing it with smaller squares, like try to do it with a 2x2 square, and obviously that's going to be a problem. Now, what about if you did it with on a 3x3? What's wrong with trying to tile a 3x3 with these 2x1 dominoes?
Well, you couldn't do it.
Why not?
There's an odd number of squares.
There's an odd number of squares. So our next case would be a 4x4, and you can play around with that too.
Yeah.
Okay. It's a cool problem. Cool math thinking problem. Good job.